Hey there, space weather enthusiasts. It's been an exciting 24 hours as we've got multiple new sunspot groups and a large major flare player just rose in the northeastern limb. You can see it on that imagery. We'll tell you all about it and lots more here at the Smash News Network, least busted name in news. This is 24 hours from Solar Dynamics Observatory, showing ionized iron and helium. Let's take a little closer look here. We've got a massive number of filaments on the Earth-facing portion of the solar disk. The likelihood of coronal mass ejections in the next 24 hours is just this side of 100%. Some growth of sunspots, some new sunspots forming in the southern hemisphere. And what we've been talking about the last few days mainly is the western limb. That has been at least the most likely place for major solar flares, and it continues to be as this group up here sets. However, and let's take a closer look at that real quick. While that has been the most likely place for large solar flares in the past few days, a new major solar flare player has risen in the east. So two new large sunspot groups just showed up there. And now we've got a high likelihood of large flares both in the northeastern and northwestern limbs of the closest star. So I believe I talked about an uptick in the X-ray flux on yesterday's daily space weather video. And that forecast has indeed come to fruition. Let's take a brief look at sunspots here, also from the SDO. That is yesterday plus today. So you'll see significant sunspot growth down here in the southern hemisphere. Two new beta gamma class groups have formed down there. And again, of course, two new groups rose up here in the northeast also. Here's your colorized magnetogram. Once again, this is depicting yesterday plus today. That is August 14th and August 15th to date. And let's see what's going on as far as volcanic activity. So these are the currently erupting volcanoes. Mount Mayan continues to produce an unknown size volcanic ash cloud. It's located on Luzon Island, Philippines. Ibu is exploding on Halmahera, Indonesia, producing a 7,000-foot plume of volcanic ash, flight level 070. Dacono exploding. Similar size ash plume there in terms of elevation. 7,000-foot ash plume over Dacono. Kilauea now, elevated seismic unrest going on under Kilauea, also major ground deformation. No sign of an imminent explosion so far. So a little uptick there at Kilauea. There are images of the Halema Uma'u lava lake there on the volcanodiscovery.com's Volcanoes Today page. Shishaldin has also increased seismic unrest there in the Aleutian Islands. Also a series of earthquakes in the Aleutians, which we'll cover here next. Elevated surface temperatures at the summit vent, also accompanied by emissions of lava in the latest satellite images at Shishaldin. Popocatépetl, we're not sure if it's exploding. Volcanic ash not detected over central Mexico. Sabancaya certainly exploding in Peru. Flight level 240. It's a 24,000-foot ash plume. Also Ubinas in that same nation exploding. Flight level 210. Please don't pole vault the caldera. It could be unhealthful. We don't want you to become part of the lithosphere. Next, seismic activity. There has been one 6+ magnitude earthquake. That's a 90-day bar graph. Here's the past 24 hours. There was a 6 magnitude earthquake here right at the edge of one of the weirdest places in the world, the Marianas Trench. I mean, The Isle of Guam is like basically on the edge of a giant cliff. The Marianas Trench there, a 6.1 occurring right on the edge of it, right on the southeastern edge of the Marianas Trench. That 6.1 magnitude earthquake there. It was at depth. Oh, only 10 kilometers depth there, so at the surface, actually. It occurred at 13:51 Universal Time yesterday, and let's hit up the list to see what else has been shaken. Prince Edward Island's region has been shaken near the Antarctic African plate boundary. That was a 5.9 at 10:39 Universal Time yesterday morning. So significant earthquake uptick here. Quite a few quakes of a 5 or greater magnitude on the list. Again, that 6.1 occurred at 13:51 Universal Time. And a quake just struck the west coast of the U.S. as we produced the video. India had a 5.3. That was at 14:49 Universal Time yesterday afternoon. So here's a significant earthquake in the Aleutians, a 5.0. Occurred there at 22:23 last night Universal Time. That was at some depth. Estimated depth there, 39.5 kilometers of that 5.0 magnitude earthquake in the Aleutians. The largest American quake in the past 24 hours. Indonesia had a 5.5 at depth, nearly 170 kilometers there. That was early this morning at 3:54 Universal Time. Peru had a 5.2 this morning at 7:06. That one was also at depth, 116 kilometers. And that latest quake that came in while we produced the video was a 3.0 at California, 700 meters above sea level. So that one occurring up on a hill somewhere. Let's take a quick look at that. Oh, okay, yeah, that makes total sense. It occurred above Lake Almanor. Lake Almanor. Hopefully it's not full of all manure. All right, so there you go. That quake, again, a 3.0 there at an estimated depth of negative 0.7 kilometers, 700 meters above sea level. Anyway, moving right along. It's time to get back to space. We've seen an uptick in the sunspots. We've seen an uptick in the X-ray flux. We've seen an uptick in the likelihood and in the actual flaring in the past 24 hours. There are the past 24 hours from SDO 171 angstroms. Let's talk stats. What do you say? The 10.7 centimeter radio flux, now at 154 solar flux units, and we're expecting a continued uptick. You can expect this to be at like 160 plus on tomorrow's daily space weather video, so make sure you tune into that. Here's a 1-year graph to contextualize. The radio flux here is the black line. The sunspot number is the red line. And moving right along to the space weather enthusiast dashboard, NOAA is expecting some geomagnetic unrest early in the day on, that would be Thursday, August 17th. So that is from a coronal hole high-speed stream. At the moment, we've got a very slow solar wind. We'll get to that here momentarily. Here's the NOAA Enlil spiral first. And interestingly, no forecast here for an uptick in the plasma density. So that should precede that coronal hole high-speed stream. We should see an increase in the density, then a decrease in the density, then an increase in the velocity. Let's see what NASA has to say. And we'd like to show this Enlil spiral as well, because this does show the interplanetary magnetic field line. That's this dotted line here. And it also shows sector boundary crossings. Unfortunately, the data is a few days behind, so we won't worry about that too much here at the moment. That's like 2 days behind there. And by the way, if you weren't aware, Wikipedia has a great series of resources about solar sunspot cycles and so forth. And of course, we hear a lot of stuff on YouTube about grand solar minima and things like this. If you actually look at the details here, you'll find that there have been solar cycles with a lot of spotless days. So days where there are no sunspots on the Earth-facing portion of the solar disk, such as solar cycle 14 between 1902 and 1906. That doesn't sound right. Anyway, 1007 spotless days during that cycle. It should be like 11 years. 11 years and 6 months was that cycle. And it is a fairly well-established fact that really weak solar cycles are lengthier and really strong solar cycles are shorter. There seems to be a relationship between the poloidal fields and the toroidal field, an inverse relationship. There's also a second analysis here, which is analyzing the minima. You'll notice that solar cycle 14 to 15 minima and solar cycle 11 to 12 minima had the most spotless days. Keep in mind that this cycle is vastly stronger than most forecasts for solar cycle 25. Taking a moment to look at Earth's magnetic moment from space as we transition from solar stuff to terrestrial stuff. So this is magnetohydrodynamic pressure for the past 4 hours out to about 12 Earth diameters. And again, we've got a very slow solar wind here at the moment, which we will report on in a couple frames from now. The past 4 hours there from space, Earth's magnetic moment, very calm. Here's Earth's magnetic moment from the ground. This is magnetic flux density at the surface level. And it is also the past 4 hours. It's courtesy of University of Michigan Geospace Model V2.0, the space weather modeling framework. And next, our planetary K-index, 0.67 there, KP 0.67 on the planetary K-index. A global geomagnetic average. And here's that real-time solar wind we were talking about. Now, we did see a recent shift here. We saw a slight strengthening of the field and a shift of the vertical component there. That's the BZ, the red line. That is the vertical component of the magnetic field as measured by the ACE spacecraft out at Lagrangian point 1. We saw an increase in the field a little bit there, and also the BZ swung into positive territory there. So that's more of a push than a pull from Earth's perspective. And check out the slowness of the solar wind. Solar wind here barely over 300 kilometers per second. Very solar minimum-like conditions. When we do see a signal coming in from that coronal hole high-speed stream, we can expect it to be a significant one. Solar wind density here just under 4 protons per cubic centimeter. More like 3 protons per cubic centimeter at the moment. Again, very slow solar wind there, 306 kilometers per second. Next, the past 3 days of GOES magnetometers data there. Those are pretty unremarkable. You can expect to see those get a little bit more chaotic as that coronal hole high-speed stream shows up. Expect that density increase we talked about earlier to show up sometime around midday tomorrow. Next, our top view ecliptic plane field plot. And we may see an extension of the South Pole current sheet, especially with the formation of those 2 large sunspot groups in the northeastern limb. So, this is just a matter of understanding the way the data ties together, folks. If you look at the latest image here, it might be a couple days yet before this North Pole current sheet arrives at Earth. North Pole current sheet depicted in green, South Pole current sheet depicted in red. And let's take a look at our line of sight field plot next. Here the sun's B field is depicted in blue. If you're wondering what a B field is, it's the field that goes through the magnet. It's sort of like a net magnetic field, the product of the north and south polar fields combined, the B field. polar fields here depicted in green and red for north and south respectively. B field in blue grayscale depicts gong magnetogram at the photosphere level. And lots of magnetic organization happening on the Earth-facing portion of the solar disk. Next is our coronal hole line of sight plot. So we've got a series of south pole coronal holes here stretching right across the solar equator. Let's bring up the last image here after that plays through once more. So there's the most current image. Keep in mind that is an hour old when we produced the video. So we've got south pole coronal holes right from the northeast to the southwest. And we've got north pole coronal holes rising here in the southeast. Next, the last 24 hours from SDO. This is 211 angstroms. So let's see. These are south pole coronal holes. This is a north pole coronal hole over here. And we've got some pretty major north pole coronal holes showing up down here in the southeast. Those will become more well-defined in the coming days, as that lumpy plasma is obscuring them a little bit, but not from the gong data that we showed earlier. Next, we'll talk sunspots. We've got some spectacular close-ups of sunspots. Looks like we'll have 4 new named sunspot groups today. So we're going to have one down here, one over here, and 2 more up here. So, all right, 3405 was already named. We'll also have 3406, 3407, and 3408, I suspect. So we'll have at least 3 new named sunspot groups today, 2 in the southern hemisphere and 1 just north of 3405. That's the most recent one to just rise over the northeastern limb. And check out these sweet close-ups. So today we're going to show close-ups in 1600 plus 1700 angstroms. There's the full disk view. And here's the equatorial zoom. Here's that group in the north center disk. This is this group right up here. And that has stabilized here now. So it hasn't grown as much as it has in the past 48 hours. Versus the past 24 hours. It's not changing that much. And again, these groups that are setting here in the northwestern limb are still certainly capable of producing large flares, including M and possibly even X-class events. More likely M-class events. And these new groups are the most active over the past 24 hours. So let's get even closer to that. There you go. That is some more sweet imagery, a 24-hour video from SDO, and you can see some of that flaring activity happening there. A bunch of ionized carbon being produced before your very eyes. It's called nuclear fusion, folks. And let's move on to energetic particles and solar flares. Now we're going to talk a little cosmology here. We're going to mix in some cosmology with this video. First, the GOES proton flux here, which is flatlined, so no spikes in that, following a subsiding of some fairly significant solar energetic particle events. That's the 3-day data from the GOES 16. And there's the same slide again for some reason. Now, yesterday, while in the process of composing our crap theory about the likely mechanism that actually underlies the solar sunspot cycles, I ran across some interesting data. So there's NOAA has a great list here of solar energetic particle events. So I figured I would share that. Here's a rundown of, from 1976 up until 2017, the most significant SEPs, solar energetic particle events. So the number you really want to look at here is the GOES proton flux, the greater than 10 mega electron volt proton fluence, and you'll see some significant events here. You'll see these numbers make it all the way up to 40,000 and beyond, actually. Of course, 1989 and 1991 both featured some pretty significant events. There's a 40,000 proton flux. There's a 43,000 in 1991. So if you're looking for a list of SEPs, that's a good place to find it. Solar energetic particle events there from 1976 until 2017. I figured I would share since I found the data. Now, if you're not familiar with four-bush decreases, four-bush decreases are when we see things like geomagnetic storms and solar energetic particle events, and at the same time we see a huge decrease in cosmic ray flux. That's called a four-bush decrease. And again, great information about those on Wikipedia. So here's one of the extreme events. This is a solar energetic particle event from, that's March of 2012 there. There was a large X-class solar flare that occurred on right around midnight on March 7th, just after midnight there. So very early in the morning on March 7th. And some relativistic particles showed up. That's solar energetic particles there traveling at nearly the speed of light, a significant percentage of the speed of light. And you can see here the Moscow cosmic ray monitor, a sudden dip in cosmic ray flux. So that's a graph of a four-bush decrease as the solar plasma effectively acts like a shield. And those cosmic ray particles coming from outside the solar system there are affected by those solar energetic particles that are, at that point, they're orbiting Earth's magnetic field lines. So those cause polar radio blackouts when that happens, but it also causes a decrease in cosmic ray flux. So that's just a graph there of a four-bush decrease. And let's do a cosmic ray update because we haven't done one for a while here. And over the past few days, we've actually seen a huge increase in cosmic rays. So we're going to start out at DOMC Antarctica, the two most southern monitors that we can find. And while it's down over the past 30 days, over the past week, a significant uptick in cosmic ray flux. DOMC Antarctica showing a similar graph. Downtick over the past 30 days, but a major uptick over the past week. Oulu neutron monitor showing a similar graph. And the past week has made it almost flat. So now keep in mind we are still seeing the lowest levels since 2004. And you can expect these to drop lower since we are still not at solar maximum. So, the highest levels that we ever saw were around 2009. The solar minimum between solar cycle 23 and 24 was the most minimal minimum in the modern age. And our regular viewers are well aware that cosmic ray flux is inversely proportional to solar activity. Let's check out some more monitors here. Here's the Mexico City showing a similar graph. And actually this one shows an uptick over the past 30 days and a significant uptick over the past week. Going a little farther north to Athens, Greece. An uptick over the past 30 days and a significant uptick over the past week. That is the Athens neutron monitor. And last but not least, Apadity and Barentsburg. So there is the Apadity, still down over the past 30 days, but actually it's almost flat over the past 30 days. And a similar graph there, so a significant uptick over the past week at both Apadity and Barentsburg. Mostly flat over the past 30 days. And let's move on to solar flares. So solar flares are a completely different thing, folks. These are photons. We've been talking about protons. And cosmic ray flux is largely made of the same stuff that the solar wind is made of. So the solar wind is primarily hydrogen nuclei. There's also a small amount of helium nuclei, also electrons, and then heavier elements also present in the solar wind. Similar components to the cosmic ray flux. Again, mostly hydrogen nuclei, ionized hydrogen with no electron as it's traveling at extremely high rates of speed. And here is the GOES X-ray flux. So there are the past 3 days, and as forecast, an uptick here in the X-ray flux. It did get above a C background level. And over the past 24 hours, it is indeed an average above C because of these flares. So we saw a nearly M-class flare there, a C9 approximately. That was at peak flux there was about 2110 universal time. And let's take a look at flares visually from the SDO. So there are the past 24 hours. And that C8.99 flare was indeed from this new active region, this new sunspot, which will remain here, the most likely place for additional large solar flares. Also still a strong possibility of large flares in that northwestern limb. So we'll be shifting the focus to the northeastern limb in the coming days. But before we do that, there are some additional close-ups of that setting sunspot group. And there is that northeastern limb as promised. And that C8.99 flare there, depicted well in 94 angstroms from the SDO. Another 24-hour video, as you may have come to expect from the Daily Space Weather Show. Next, a star chart. This is our own star chart for Lehigh Valley, Pennsylvania. And we've got the sun here just coming up over the horizon. And Venus just to its south there. As Venus slowly becomes a morning star, Saturn sets there over in the west, Jupiter high up on the ecliptic. That's skyandtelescope.org if you want to make your own star chart. And if you want to find Betelgeuse, a great way to do that is find Orion's belt. The middle star makes a perpendicular line from the belt stars to Betelgeuse, the red supergiant. One of the more obviously red stars visible with the naked eye. It's actually the largest object visible to the naked eye. The largest single object, at least. Of course, you can see galaxies. And let's do a solar system forecast. So here's where stuff is today. And for all you heavenly bodies out there, here's where heavenly bodies will be in 1 week. New moon looks like it's coming tomorrow. In 1 week, we will have a crescent waxing as Venus slips past Earth and Mercury plays catch-up. Next, the astronomy picture of the day, and that's from Violeta Goreka over Iceland. That is some spectacular imagery indeed. Looks like a geothermal plant over there. And here's a close-up of those aurorae. Some green curtain-like aurorae there, as well as some pink aurora showing up over the volcanic island nation of Iceland. Certainly on my bucket list. apod.nasa.gov if you'd like that on your desktop. And a brief look at some other cosmology articles here. Now, we covered this actually right when it came out, but I figured I would retouch this as it did come up in yesterday's travels. Did you know that there are some sources that can produce energies of petavolts? Petavolts are more than 1 quadrillion electron volts of energy. 12 gamma ray hotspots harboring the galaxy and the galaxy's most energetic particle accelerators. Interesting article about that on Science News. Producers of over 1 quadrillion electron volts there. And of course, a lot of people for some reason thought it was new information about gamma rays coming out of the sun. However, apparently it was known about all the way back in 2017. So Fermi did detect this several years ago. Gamma rays being detected from the closest star there were not known by most. However, it's actually not really anything new. So, yeah, gamma rays. The sun produces them. And there's even evidence that gamma rays have been produced from Earth. Yeah, gamma rays have been detected coming out of the Earth. So that's, if you've got theories as to that, feel free to leave them in the comments, or better yet, drop by our forum. If you haven't seen it, smashomash.com/forum. It also contains our mission, which is to assist, study, and report on the ongoing formation of a unified theory of physics. And our .com is a little bit more complicated than our .org. It's also to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations, multiply our reach through videos like this one, to demonstrate cutting-edge proof-of-concept solutions to problems, to publish scientific papers, which I spent most of yesterday composing one about my crap theory. Also to assist mankind by advancing the study of predictive phenomenon, optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. You know, we've got potatoes growing in the living room. Maybe we'll make a video about that sometime. Also to not be ossified in our beliefs, and to treat those who are ossified in their beliefs with love, respect, and inclusion to the scientific discussion. You can read all about the mission and post your own information if you like at smashomash.com/forum. It's completely free. We established this years ago as we realized that we need to host some information to make it convenient for our viewers. You can share your own information about everything from cosmology to whatever you like, as we are promoters of all legal speech. You can post information, theories, product ideas, even recipes. There's even a dream log on there. So check it out, smashomash.com/forum. Huge repository of information, and it's only getting bigger. Next, we're moving on to coronal mass ejections. Here are today's images from George Mason University. That's yesterday's images, August 14th. 101 frames, and there were at least 2 CMEs. And let's make it 3, as late last night, a more significant event came out of the northeastern limb. There's also a huge filament up there ahead of those sunspots, which we'll cover here in a minute. So those are yesterday's coronagraph images. Let's move to today's coronagraph images. There are an additional 45 frames from today. And again, folks, the likelihood of coronal mass ejections in the coming 24 hours is 100%. I'll say 99.9%. It is possible for none to happen. However, it is extremely unlikely. Expect more CMEs. So we paused this here at the most significant event, the Soho-Lasco C2 and C3. These coronagraphs are located at Lagrangian point 1, and we paused this here late last night, 2124 for the C2 and 2318 for the C3, because we want to see if any of these CMEs contain earthly directed components. So it doesn't look like it. It just looks like an interesting light show. So let's actually blow these up, but first, let's talk about Stereo A. It's looking funky. And we put up a tweet about it just earlier this morning. So asking some people who know more about the spacecraft than I do on Twitter what's going on with Stereo A. And here's what we're talking about. Check out Stereo A over here on the left. It is, yeah, I don't know what the deal is with it. If it's not pointed at the sun correctly, which is messing with the contrast, I don't know. I don't have a theory, which is why we asked people like Dr. Keith Strong, Tamitha Skov, Erica Palmerio, and Scott McIntosh, PhDs who know a lot more than I do about it. So anyway, here's Soho Lasco C2 and C3. Let's sync these up a little bit better here. Once again, we don't anticipate these coronal mass ejections being earthly directed, but the possibility for an Earth-directed CME is quite high because, well, a massive number of filaments are draped across the Earth-facing portion of the solar disk, which we're going to show you here next. So here's the ground-based El Teide Spain Hydrogen Alpha telescope. And here's another great filament that deserves to be named. Check out how huge and dense that filament is right there. That is one massive filament indeed. And since filaments are lively, we name them after live humans. A number of these filaments are already named. If you want to name filaments, you got to do it on Twitter. If you don't have an account, go make one. If you've unplugged entirely from social media, we don't blame you. Especially with the pathetic state of censorship currently on the internet. So that's the El Teide Spain colorized imagery. In color imagery, I should say. And here is the grayscale, which shows prominences, unlike the last images, which cut off right at the solar disk. So that's what's going on. Lots of filaments. Likelihood of flares goes up. And likelihood of coronal mass ejections is just this side of 100%. Next, the past couple of hours here from the GO 16 SUVI. Which brings us to bonus features. First bonus feature is satellite charging hazards. We don't have any. Satellites are experiencing a clear environment there. No low energy electrons to build up on the outside of them. No high energy electrons to build up on the inside of them. The GOES electron flux here, seeing a little bit of a dip, and you can expect to see this crater. As the coronal hole wind stream shows up again around midday tomorrow, you can expect maybe even earlier than that, but yeah, expect that to be much lower in the coming days. There is the 1 year greater than 2 mega electron volt electron fluence from Solon.info. High to moderate levels, expected to drop significantly. Here's NOAA's forecast, and NOAA seems to agree. No surprise there to our regular viewers. The green boxes are the forecast, and the yellow diamonds are the observation, by the way. Next, we'll look at the layer of the atmosphere where it's measured. They use radiography, the GOES 16 and GOES 18, to measure the electron fluence. At the F layer, which is located at 300 kilometers of altitude, feel free to pause the video on this frame if you're not familiar with the information depicted. Here's the vibrational frequency courtesy of Australian Government Bureau Meteorology. So that's the Ionosphere. We show it daily on the channel. One of the many, many features of the Daily Space Weather Show. And once that plays through, we'll show the anomalygram as well. That's the raw vibrational frequency in megahertz, millions of vibrations per second. And here is the anomalygram. That is anomaly in megahertz from the 30-day median. Now, keep in mind, folks, as we get closer and closer to the September equinox, we can expect geomagnetic activity to increase because of the Russell-McFerrin effect. It has to do with the acceleration of relativistic electrons in the outer Van Allen belt, and it has to do with the orientation of Earth's magnetic field with respect to the incoming solar plasma. Anyway, there's the latest intensitygram, the latest ionogram, 10:45 Universal Time, and there's the latest anomalygram, 11 o'clock Universal Time. Total electron content is free electrons to about 12,500 miles of altitude. That's approximately where your GPS satellite orbits. And the coupled thermosphere, ionosphere, plasmasphere electrodynamics model depicts the most likely places to see GPS errors, and it also gives us some insight into what's going on in Earth's magnetosphere. So as we bring space weather from the sun all the way down to Earth, we're getting closer and closer to our meteorology segment. That's your total electron content forecast. We normally also show the North American total electron content anomaly. However, it hasn't been working. Check it out. I'll press refresh here just so you see what I'm talking about. The anomaly will not load. Standard deviation doesn't really show anything, and neither does the total electron content. So we'll skip that, show the latest solar intensitygram and magnetogram, and let's take a look at these groups as they set. Certainly beta gamma class. I'm not so sure if it's beta gamma delta class. Let's take a look. Some small deltas here at the back side, so it is beta gamma delta class. It still does harbor the kind of magnetic fields that can produce a large solar flare like an M or even X class. Next, this group. Some small deltas there as well. Keep in mind the Earth-facing quiet does affect this. However, it is capable of producing large flares. These groups down here have got some honorable mention as well. That's at least beta gamma class. This group over here, at least beta gamma class, as it does have both polarity umbrae. And last but not least, let's take a look at these groups. The new biggest flare players. There we go. So this one's beta gamma delta class, but just barely. Just a small trailing South Pole umbra there, right there. And yes, it's true, folks. You too can forecast solar flares. It's just a fact. It has to do with the magnetic shear, and it's just a fact. We are a fact-based channel, by the way. We avoid pseudoscience, nonsense, propaganda, fraud, grifting, etc. Please support the channel if you enjoy the content. Press the like button. Press the subscribe button. I mean, the videos contain shocking amounts of data, and the accuracy of the forecasting is similarly shocking. Our regular viewers will attest to that, and our Smash Team members will attest to that even further, especially the ones who trust us with an entire year of content by becoming a gold annual paid-up Smash Team member. So press the like button, press subscribe, share, etc. Leave a comment, whether derogatory or not. It's not going to hurt my feelings. In fact, we welcome derogatory comments, and we welcome you to support the channel via our paid affiliate links. One of them is the Hemp Lucid link. If you are a CBD shopper, why not buy them through our affiliate link? Help out the channel that way. Check out the mushroom gummies. I'm a big supporter of both the focus and the stress mushroom gummies. There's also sleep mushroom gummies, immune stacks, CBD body balms and lip balms. Lots of products available there at the great Hemp Lucid. Links below this video in the description, as well as on the homepage at smashomash.com. Another place you can find some products is our Amazon shop. Thanks to everybody who's been picking up products from there. Amazon.com/shop/smashomash. Also linked below this video and on the homepage, smashomash.com. Today's featured product is food-grade diatoms. Yeah, food-grade diatoms. Those are the ones that come from fresh water. Basically, it's a bunch of glass. And yeah, it's what you would call an extremely powerful, an extremely safe, an extremely non-toxic anti-parasitic insecticide. Diatomaceous earth food grade. Available there on the Amazon shop, along with many, many other products. So check out those product lists. Amazon.com/shop/smashomash. Last but not least is today's featured product. And we've been making featured products for a long time. Some of them are more controversial than others, I suppose. Today's really shouldn't be controversial at all. It's a product management fact. And by the way, you can save 30% on all items at Redbubble. Links below the video to the Redbubble shop, as well as on the homepage. This product is pick two, because you can't have all three. Your project, if you'd like it to be fast and cheap, don't do it. Don't do a project fast and cheap. Why? Because it won't be good. So stick with the other possibilities, where it's expensive because it's good and fast, or it's slow because it's good and cheap. You don't get all three. And if you know a project manager who thinks the project is going to be cheap, fast, and good, they should probably be replaced with somebody who isn't clueless. Again, save 30% site-wide at our Redbubble shop on literally everything. Project management facts. No project is cheap, fast, and good, so pick two. And we're going to pick up the pace here a little bit as we've moved into our meteorology segment. Check out all the Saharan dust, a massive amount of Saharan dust here over the central Atlantic Ocean. That'll be tamping down tropical systems. So if your wish list included hurricanes forming in that area, you can forget about it. That area is not going to be producing any hurricanes anytime soon. So if you're hoping for a disaster spawned by a hurricane, you better hope it forms someplace else besides there, because nothing doing for convective forces with all that dust. So that's your Saharan dust report. And here comes your wind report. Check it out, some Australian dust there blowing off to the east. Interesting, interesting. All right, anyway, here are the surface winds of the eastern world. Here are the jet streams of this side of the planet. Here are the jet streams of the central world, like Africa, Europe, and Central Asia. Here are the surface winds. Surface winds of the Americas. And here are the jet streams. By the way, if you wanted to pick only one piece of weather data to forecast large-scale weather patterns, pick the jet stream. It's quite good. Anyway, here's our windy.com map, and we've got two significant lows over the eastern U.S. One here is just north of the Ohio-Indianapolis border there. That's the stronger low. And there's one here moving across Pennsylvania as well. Around Harrisburg right now, that weaker low. Here's your full globe map. Strong low there over northern Canada. High pressure over Greenland. And a large anticyclone here. An upper level high pressure zone over the northern Pacific. All right, so here is clouds and fog over the Americas. This is the shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite. It even depicts clouds and fog at nighttime. If you want to know whether you'll be able to see the stars without actually going outside and looking, try the shortwave radiation map. Here is our weather.gov map. If your location is lit, head to weather.gov and click your location. There are too many counties with weather warnings there for us to cover. We've shown the key. We've shown the maps. And here come some forecasts. First, the GFS 72-hour jet stream forecast. Since there is a lot of high temperature stuff happening, 72-hour GFS temperature anomaly forecast in degrees Celsius. No respite coming to the Pacific Northwest yet. Also, Texas seeing anomalously hot temperatures for this time of year. Next, your total accumulated precipitation forecast. This is in inches. It is for the next 72 hours, and it is the GFS model. The 72-hour GFS total accumulated precipitation forecast in inches. And like we said yesterday, 5 inches of rain coming to Michigan. There'll be a second wave there to add insult to injury, as you can see at the end. And lastly, here is the GFS 72-hour pressure and precipitation forecast. Moving right along to the NASA GOES lightning mapper. That's from about 1 o'clock Universal Time this morning until about 10 o'clock Universal Time this morning. And here is the current map from lightningmaps.org. We'll zoom in on the U.S. to see if there are terrestrial strikes, and indeed, southern Arkansas here. More like northern Louisiana. Just a minor cell there, nothing too serious. Pretty calm as far as lightning over most of the U.S. By the way, if you enjoy the content and you'd like to support the channel, become a member of the Smash Team. We send out email alerts for videos just like this one, even to bronze level Smash Team members, which costs $0 per month. There's also a silver level, which entitles you to more content. And most importantly, the gold level. Gold Smash Team members, if you didn't see yesterday's post, I composed a large portion of the CRAP theory yesterday, the CRAPF theory of the solar sunspot cycles. I think I've got them explained, and it'll cost you $9.99 a month in order to see that theory, that hypothesis, I should say. It's not quite at the level of a theory yet, as it would have to be a little bit more accepted to be a theory. Don't confuse theories and hypotheses. Theories are hypotheses that are backed up by lots of additional evidence. This is a new idea, and so at the moment, it is a hypothesis. Smashomash.com/SmashTeam. Again, we send out email alerts for things like disaster reports, also tsunami alerts, and so forth. So check it out. It's our own custom subscription services site that we launched back in October of 2021. You can find links on the homepage at smashomash.com. And by the way, welcome to the Neo Renaissance. This is not a cult. This is a good faith science operation. We are interested in advancing the science, advancing human technology, and advancing cosmology. That's what brought me to heliophysics. I almost majored in it in the mid-90s. However, I had things to do, like be a pro cyclist. Anyway, we'll close out with the latest U.S. Doppler radar map. And then we'll show cloud cover and water vapor over the lower 48. So a lot of moisture here moving out of the New England region there up toward Nova Scotia. Shout out to Ricky, Julian, and Bubbles. Here is the clouds and fog map. You can see that strong low there over southern Michigan. And it'll be even more obvious on the water vapor map. It is largely constrained there by dry massive air depicted in the orange and yellow color bands. And here's your recap. U.S. Doppler radar depicting vertical motion in the air column. Clouds and fog. It's 3.9 micrometer infrared radiation. And there is water vapor, 6.19 micrometer infrared radiation, depicting all of the water vapor. And when your Doppler is unclear, the water vapor will guide you, especially if you understand atmospheric physics. Anyway, I just blew myself off. I'm back, but I'm out. So thanks for tuning in. Congratulations on realizing the Smash News Network least busted name in news exists. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.